Hey there. My name is Mr. Lucan. I am one of the math teachers here at Rouse. Kind of a weird time. I'm going to be putting together some videos that hopefully we can get some normalcy back and teach you some of the math that you're missing out on. Definitely wish all of us math teachers wish we could do this in person. But as it is, we're going to have to, at least for a little while, do this distance learning thing. So I'm going to be, whether you have me or Miss Lyseth or Miss Poppy, whoever you have for intermediate algebra, Mr. Anderson, I can't name them all. I'm going to be the one kind of guiding you through the slides, and then we will go from there and try to, again, make this as normal as we can. So this is kind of what my setup looks like. You'll see my face down here in the lower right-hand corner of your screen. These are the slides that I would go through in my class. So we're going to run through these pretty quick. I have my calculator over here, which doesn't seem to want to work right now, which might be an issue, but we'll deal with it. Yeah, and I'm going to try to make the videos less than 15 minutes, 10 to 15 minutes. Keep it short, get you the information you need, and that way we're not using all your time. So I'm going to go ahead and get started. And yeah, hopefully we can get through this. So we're actually going to skip the rest of chapter 7 and start out in chapter 8. We're shifting away from all the linear stuff, the y equals mx plus b, and we're going to get into equations and graphs that have powers in them instead, exponents. So before we get going, we want to go through a quick little video and get some vocabulary out there so we all can use the same language when we're talking. So here's what the slides will look like when you tune into the videos. 8.1.1, it just means chapter 8, section 1, video number 1. I have the title, Adding and Subtracting Polynomials. The topic for the day is adding and subtracting polynomials. Again, that's usually just a repeat, but I like to emphasize what we're doing. And then our EQ for the day. So today's EQ is, what are polynomials and how can I classify them based on their degree and number of terms? And this first video is going to be pretty vocab heavy, but I'll try to move through it as quickly as possible. And the nice thing about video is if you miss something, you can go back and rewatch it. And then we will be available for online discussions. Your individual teachers will be, if there's something that I say that doesn't really make sense. So we're going to start off by doing some combining like terms, which is something we've done before and we're familiar with. Just to kind of start out, when I say combine like terms, this first expression has 4 terms, 1, 2, 3, and 4. So 20x, positive 8, negative 6x, and positive 12. So if I'm going to combine like terms, we know that like terms can only be combined if they have the same variable. So here I have 20x minus 6x. 20 take away 6 is 14, so those can combine to be 14x. And then over here, I have a positive 8 and a positive 12, and those can combine to be plus 20. I cannot combine 14x and positive 20 together because 14 has a variable x with it, and 20 does not. So that is fully simplified. We went from 4 terms down to 2 terms. Here I see I'm starting with 5 terms to begin with. 1, 2, 3, 4, 5. And if I look at my first term is 11x, and I have another x term over here, 11x. And now here's where you want to be careful because it's 11 take away 18, which is negative 7, and then I keep the variable the same. My next term, minus 5y, has another y term that it can combine with. Now this is plus 1y. Right? If there's no number in front, which is called a coefficient, we can put a positive 1 there. And so if I combine negative 5y and plus 1y, it's minus 4y. And then finally, this last term, plus 7, is all by itself, so we just leave that alone. Okay, so in the first one, I went from 4 terms down to 2, And the second problem, or the second expression, I went from 5 terms down to 3. So that's combining like terms. Let's get into a little bit of vocab here real quick. A monomial is just another name for a term. Okay, mono means one. It can be a number, a variable, and its exponents. Okay, so for example, 6x squared is a monomial. It's the same thing as a term. The degree of a monomial is simply, we're going to talk about what's the degree of a term, and the degree is the sum of the exponents, but the exponents that are only on the variables. Okay, so x, y, z, the letters. Okay, so if I look here, I have x to the second power, so this thing is degree 2. The next monomial, or the next term, is negative 13 x to the 5 y to the 3. There's 2 different variables, and if I add up their exponents, I get 8. So that term is degree 8. Okay. The number 19, something just like 19 can be a what we call a monomial or a term. Since there's no variable in this, that is degree 0. Okay. My next monomial has 3 variables in it, x, y, and z. And their powers are 7, 3, and then there isn't a power on z. So if there isn't an exponent, I don't want to think of that as 0. I do want to think of that as z to the first. So 7 plus 3 is 10, plus 1 is 11. So that term is degree 11. And then finally here I have x to the 7th over 3. That dividing by 3 is the same as saying, that's the same as 1/3 x to the 7th. Okay, so it doesn't really matter whether I put the 3 on the bottom of its own fraction or if I put the 3 underneath x to the 7th. But there's one variable, so that thing is degree 7. Okay, monomial is the same as term. Degree is just adding its variable exponents. Okay, now we're going to talk about this idea of naming an expression or classifying. Okay, if an expression, which is just a set of terms together without an equal sign, if an expression has 2 terms, we use the word binomial. So monomial is 1 term, binomial is 2 terms because the prefix bi means 2. Okay, and then a trinomial, if an expression has 3 terms, that's what we call a trinomial. If it goes more than 3, we're not going to get into like weird quadnomial or anything like that. So we're just going to use the word polynomial for anything that has more than 3. And technically, poly just means multiple. So you could use a polynomial or polynomial for 2 terms or 3 terms. But for sure, if it goes more than 3 terms, we want to call it a polynomial. Okay. So for instance, I have this right here. This expression, 10x to the second plus 18x minus 7. Okay, I have 1, 2, 3 terms, and before I call it anything, I want to check, can I combine any of those terms together? X to the second and just plain x cannot be combined because one has a power and one does not. So these are 3 separate terms that cannot be combined. So I call this a trinomial. Okay. 3 terms, that is a trinomial. The next one, 8x to the second minus 15. Those are clearly, 8 has an x squared, 15 does not. So that is a binomial. Okay. Over here, I see I'm starting with a bunch of terms, but again, I want to check to see, can I combine any? And I see 10x squared, but there's no other x to the seconds in the problem. So I'm just going to keep 10x squared there. My next term is positive 10x, and I see I have a couple other terms that are also just plain x's attached to the coefficient. So 10 plus 8 is 18, take away 2 is 16, so all 3 of those can combine down into just plus 16x. And then finally, not red, minus 15 is a plain number, sometimes called a constant. And so we're just going to keep that the same. So this, even though it started with 5 terms, we were able to condense it or combine it, simplify it down to 3 terms. Okay. And then finally here, I see I have 3 terms, but I do see that they're all x to the second power. So that means I can combine their coefficients, or again, those numbers in front. 7 plus 12 is 19. And if I do 19, take away 15, that is 4x squared, which means this is a monomial. It's a weird word. Monomial, single term. Okay, so make sure you are combining like terms if you can. Okay, next thing is we're going to write an equation, or sorry, we're going to write an expression in standard form. And later on, when you study more math, it's going to be easier to just make some decisions on or predictions on what you think is going to happen if your expression's written in standard form. What I mean by standard form is that the terms, the individual terms, are going to be written in order from highest power or highest degree down to lowest degree. So biggest degree or biggest powers go first, all the way down to lowest degree, which would just be like plain numbers like 10 or 15 or -2. So here's an example of something that's already written in standard form. I have my first term is x to the second, so that's degree 2. My first term, or sorry, my next term is x to the first power, which is degree 1. And finally, my third term at the end is the number that doesn't have a power at all, no variable. Okay, it is not rearranging from biggest number to lowest number. So it's not 16, then 10, then -8. It is in order from biggest degree or biggest power down to lowest. Okay, so that's already in standard form. Here, again, I see I have 3 terms. They are all different degrees, so I cannot combine them. But which of these 3 terms should go first? Because this 2x to the third has the power 3, that gets to go first in standard form. Okay. Then I bring plus x, because that's x to the first power. And then finally, I end with -15, because it does not have a variable. Okay, that's what we call standard form. So think of it as rearranging. Biggest power first, down to lowest power, aka just plain numbers. So if you would, now there's one other thing I wanted to mention and I didn't, and I want to make sure this is clear. This trinomial, okay, there's 3 terms there, right? The first term is degree 2. The second term is degree 1, and the third term is degree 0. And here's what's going to be kind of confusing, but I want you to just practice with. Since these are 3 separate terms, degree 2, degree 1, degree 0, this entire trinomial is degree 2. Okay? I am not adding those 3 degrees together. This trinomial is degree 2 because that's the highest power I see. The only time you would add powers together is if a single term had like x and y together. Okay, so this whole thing, this whole trinomial is degree 2. This trinomial, because my largest power is 3, is degree 3. Okay, so when we say what's the degree of the polynomial, you are looking for the highest single degree that shows up. Okay, so at this time, what you're going to see is from time to time, usually once or twice a lesson, there'll be a you try slide. I'd like you to pause it, try these couple problems, see if you can rewrite them in standard form. So rearrange it highest to lowest, and then find the degree. Okay, I'm going to go ahead and just do it, but at this point, if you could pause and try these problems, that'd be awesome. Okay, so I have 3 terms here. 1, 2, 3. They're all different degrees. So my power 4 is going to go first. My exponent or power 3 is going to go second. And my power 1 is going to go last. So this is in standard form. And this whole thing is degree 4 because that's the highest power I see. Okay, so we would say that's a trinomial because there's 3 terms and it's degree 4. If we take a look here, again, I have a trinomial, 1 term, 2 term, 3 term. What's nice is the biggest power is already at the front, right? My 6x squared is already at the front. But then plus 22x has got to be the next term. And don't forget the minus sign with the 15 when you move that to the end. This is, again, a trinomial, but it is degree 2 because that's the largest power or largest degree term that we have. Okay. Next one, we got 4 terms, power 1, power 3, power 2, and power 0. So that means I can't combine any of them. So negative 19x to the third plus 16x squared. Now, there's no plus sign here, but since I don't see a negative sign, I assume it's plus, and then minus 27. So I've rearranged. This is a polynomial because it has more than 3 terms. And the degree of this is 3 because that's the largest power I see in the problem. Okay, and finally, this last one, I have 2 terms, 18 and negative 6x. Those just need to be swapped because the negative 6 has x to the first, and then the 18 has no variable, so it's power 0. This is a binomial, and it is degree 1. Okay. All right. Combine like terms right in standard form. So this would be another you try. All it is adding the combining like terms together. So I'm going to go ahead and skip this slide because I think we've already kind of worked that in the video, and I'm kind of pushing my time limit that I set for myself. So to end every video, we're going to have a summary. Okay, we have an EQ, and the EQ is the essential question, and so we need to answer the essential question. What are polynomials, and how can I classify them based on their degree and number of terms? So what I'm going to do here is I'm going to say, first of all, we want to combine like terms. Okay, that is always going to be our first step. Number 2, after we combine like terms, is to rewrite in standard form which, again, just to remind ourselves, is largest degree to smallest degree. And then we have 2 ways to classify, or 2 types of classification. Classify by degree and the number of terms. And number of terms meaning monomial is 1. Yeah, I don't like that. Monomial, binomial, trinomial, or polynomial. Okay. So that's going to conclude the first little lesson for Chapter 8. Hopefully my voice wasn't too boring, and the following videos will be shorter.